Continuing the COVID-19 story here is Cambridge University virologist Dr. Chris Smith back again. Hello, Chris.
Hello, Kim.
Let us speak about hydroxychloroquine. It's official. The drug promoted by President Trump does not cure COVID-19, according to an Oxford University trial. However, neither does it increase the risk of death, reports of which were based on, it seems, unreliable data, published in The Lancet, now retracted. This is quite a saga, isn't it?
Yeah, it's very unfortunate too, isn't it? Because as Richard Horton, who's the editor of The Lancet, has come out and said, it's pretty appalling, actually, what's going on at a time when people are trying to fast-track research in order to get treatments to people who are really vulnerable from this. And we're really, really desperate to find ways to manage this outbreak and get the world back on its feet. And for this sort of manipulation to be happening, we assume manipulation, is not good. And the backstory to this is that the work was done using data which was provided by this independent agent, Surgisphere, and they provided information on a large number of cases of COVID. And an Australian journalist spotted that there appeared to be more cases recorded from Australia than Australia had actually had in total, and asked some hard questions which were difficult for them to answer. And these suspicions led to more ripples and rumbles, and more people then asked more hard questions, and the originators of this data have failed to provide their original source data for further scrutiny. This destabilised our confidence in the manuscript, and the lead author asked The Lancet to retract it. That meant that we went from a situation where we thought hydroxychloroquine, this Lancet paper says bad news, this might kill you from heart disease or heart problems, as well as not being terribly good for management of coronavirus. And then it leads to the WHO pulling all their trials. Other trials are stopped of using hydroxychloroquine because of the alleged risk. Then it emerges the paper's on shaky ground, so that gets pulled. Then these trials go back on again, and in the wake of that, the trial in Oxford, which was going on, is one of the world trials into hydroxychloroquine. This is called the Recovery Trial. They'd actually recruited thousands of people who had been infected with coronavirus and were receiving or had received the hydroxychloroquine intervention or a placebo. The people who are the ethicists behind that trial actually asked that the trial be unblinded. And this is an unusual thing to do, but what that means is that you then look at the data so far, you see what the outcome is at an earlier than you would have done stage, and if you see a clear direction of travel, then you can implement changes off the back of that, because the recovery trial in Oxford is judged to be the gold standard, because it was a blinded placebo-controlled trial. In other words, people are recruited, they don't know what treatment they're getting one thing or the other, no one knows what they've had, you just look at the outcomes, no risk of bias. And they looked at literally thousands of people, and they found no evidence that it's worth pursuing hydroxychloroquine as a treatment intervention for coronavirus. I'm not sure that they found an excess of heart problems either, but this remains a theoretical risk. Hydroxychloroquine and its chemical relative chloroquine can do things to destabilise the electrical rhythm of the heart, but these drugs have been used in very safe capacity by a million people over the years for a range of different indications, so we've no reason to think that that risk is any different now.
Is this part of the problem associated with the rush to publish because of the urgency of the situation?
I think partly, yes. The person I spoke to last week, who we're collaborating with in Australia, said to me, I think there's something like 10,000 peer-reviewed papers gone through in the last 6 months on SARS-CoV-2, the cause of COVID. And the preprint servers, these are systems that have been set up. It's become very much en vogue in recent years not to hang on to your research for ages while a journal considers it, peer reviews it, and then publishes it. What you do is you put it on what's called a preprint server. It gets time-stamped and is visible to the world. People can then appraise it in an easy-to-access, free-to-access way. And then, while that's happening, you can feed it into a journal. And the submissions to those sites have gone up by 400% to 500% in recent months. So there's a huge tsunami of research coming through, and people are trying to fast track things with good reason, because if you find something that really makes a difference, you want the message out there. And for instance, we had a very important paper from Cambridge University recently where we'd actually been screening healthcare workers, and we found that about 3% of healthcare workers were coming to work. They had no symptoms whatsoever. They felt absolutely fine, or if they did have any symptoms, they were so mild they dismissed them as of no consequence. And that 3 to 5% of healthcare workers were actively engaging with patients, but they were infected with coronavirus. This was a real stimulus to make sure that workplaces do proper screening programs for their staff. And this was fast-tracked to publication by the journal eLife because they recognised the importance, and they managed to turn it round in, I think, the record I've ever seen for a peer-reviewed published paper, which was 3 or 4 days. They worked over a weekend to get it out there. So journals are going above and beyond to do this, but what is inevitably happening is that when you get a system or a situation like this one, you can quite quickly see the foundations collapse out of it, and everything comes down like a house of cards quite quickly if things go wrong.
Let's look at Sweden. I mean, the debate will always go on about whether a lockdown's too hard or not hard enough around the world. Sweden did not lock down as hard as its Nordic neighbours, and people went, whoa, well, this is interesting. Now the state epidemiologist either admits they got it wrong or says they could have got it righter. What's your reading of Sweden's situation? Well,
I actually spoke I was on a radio programme yesterday with the Swedish head of science for her radio station, her radio network, and they actually were one of the people who sort of broke that scoop of this person coming out and saying they could have probably done more. They didn't say that they got it wrong. They haven't said that they've messed up. What they've said is that they acknowledge that there is more they could have done probably, and done things in a slightly different way. What still remains to be seen, though, is what the numbers are going to look like right at the end of all this, because what we just
they're not looking good now, are they?
No, they're not. But then what we don't know is whether, as you have reported on your own programme, there's going to be a situation of we're just kicking the can down the road in some countries, and in fact this is just going to be a slower burn in those countries, and the same numbers of mortalities are going to occur. They're just going to take a long time to get there. We don't know, and it may be that is what happens. We don't know, but at the moment Sweden acknowledged that perhaps they could have protected certain sectors of society, and I think we all now realise, in countries like the UK, there are particularly vulnerable people. We probably should have moved faster to protect those people, so that we could have minimised the attack rate in those vulnerable communities sooner, and then we would have probably had lower rates of mortality. But the problem is, it's easy to be wise in retrospect, and the evidence we've got is this thing was in many countries far sooner than we realised, much earlier than we knew, and it was already circulating. And it was like trying to stamp out multiple bushfires when you can't even see the fire burning. It's sort of smouldering invisibly behind the wallpaper. A former head of MI6 has said that he believes that COVID-19, this coronavirus, accidentally escaped from a Chinese lab. This is a minority view. Does he have science on his side? This is Sir Richard Dearlove, and he has been citing some research which involves a researcher from one of the London institutions, Angus Dalgleish. And what this piece of research claims to show, and it's been rejected by a number of journals but finally accepted by one, is that they started out by writing incontrovertible proof, and they've watered it down a bit, that this is not a natural virus. Now, incontrovertible doesn't sound like a very scientific thing to say. No, and I think it's probably why it's been bounced a few times. But the thing is, what we do agree on is that this is a new virus. We agree it seems to have originated in China. The word on the street is that it originated in China in a wet market. And China has form for this, because that's how SARS got started, about 2003. And someone brought a consignment of bats to a market. They were in the market with a civet cat, or a bunch of civet cats, and a virus jumped from one to the other amplified in the civet cats, in other words, increased enormously in terms of how much virus was there and jumped into people. And people have post-mortemed that very thoroughly, and they're happy that that was the mechanism. So when this thing emerged, everyone said, well, that must be the same thing going on again, though, because it's so similar to this bat virus that's in the database. It's got a chunk of pangolin in it. Both things are found in these markets. Therefore, the same things happened. History has repeated itself. But that doesn't mean that that's absolutely the case. It doesn't mean we should not keep an open mind. And so while it seems like a plausible theory, there is a track record there for this having happened before, showing that this can happen in these sorts of environments. It does need further investigation. And Julia Gillard, the former Prime Minister of Australia, has recently been appointed as the next head of the Wellcome Trust, one of the world's foremost biomedical research charities based in London. And she has said she intends to use that platform to promote an international investigation into this. Not to point the finger, she emphasises, but to encourage learning. In other words, because this has now happened twice in under 20 years, and therefore we need to find out why it keeps happening in China, and the fact that it's devastating for the world, what we're actually going to do to try and mitigate this in future. And of course, if China's got nothing to hide, I'm sure they'd be very happy to cooperate.
The argument seems to be that the DNA changes, the genetic changes that are observable in this coronavirus, if it came from bats via something else like pangolins, the changes are so great that they couldn't have happened without human intervention. Is that the argument?
Well, there's a number of researchers, one Australian researcher, Nikolai Petrovsky, who has said this is better at binding onto our cells than any animal cell. So either it's a real freak of nature or it was man-made. So, the jury's really out at the moment. If you look at the structures on the surface of the virus that do the binding onto our cells, they're extremely well optimized for our cells, but then you could argue that's how evolution works, because if you get a virus that can do it better than all of its friends around it, then that's going to be the one that's going to succeed more often, so you're going to make more of those viruses than the ones that are less good at doing it, and it's a process of selection with natural selection. And that's how nature has optimized each and every one of us and each and every species on Earth. So it's perfectly plausible that this sort of thing can happen, but it does seem to work really rather well. But at the moment, people are beginning to look into this in more detail, and I think pressure will be brought to bear on China to be open and transparent. There's evidence that they have got form covering things up. They forgot about, quite a few large numbers of deaths, something like 1,500 deaths were accidentally overlooked. It's easy to do, isn't it? And that they have also been unforthcoming in other respects, and there's been other concerns expressed about the laboratories and the work they were doing. I mean, what's got people slightly anxious is there is a virology institute in Wuhan working on bat coronaviruses, working on ways in which they can be tweaked to make them infect human cells. So you do have to wonder, and I'm sure they've got nothing to hide, and they'll be very forthcoming and open and transparent with their sharing of all their data to appease the world.
You're being disingenuous, aren't you?
I'm just saying that China has form in this area, and they told us back in, I was watching the ambassador to the UK on British television back in February time, while in the background, playing out behind him, were scenes of the two enormous hospitals being built from scratch outside Wuhan, and they were saying, the whole world's overreacting. China has saved the world from a pandemic. You should be thanking us. You're all overreacting about this. And we're saying, well, actually, you're saying that, but why are you building 2,000 beds worth of hospitals outside your city then? Why are you doing that in under 2 weeks if everyone's overreacting? And they didn't really have an answer to that.
Let me ask a listener question. Do some people who are exposed to COVID-19 just not become infected with the virus and not generate an antibody response as their non-specific immune system deals with it before a specific immune response is necessary?
We don't know.
He says it seems to him, well, you don't know.
No, we don't know. I mean, so it's what he's getting at is that you have something called your innate immune response. The immune system has two arms, the innate response and the adaptive response. And the innate response is that whenever you get something that tries to get into your cells, viruses and whatever, they trip over various tripwires, biochemical tripwires wired into our cells, which sound the alarm. And it puts in train an enormous number of responses with cells beefing up their own security. And they also send all these alarm signals to adjacent neighbouring cells saying there's a burglar in the neighbourhood, bolt down your shut the shutters, bolt yourselves down. Put yourselves into lockdown, as it were. And that makes it much harder for viruses to actually get in and spread. And this defends us all the time without us realising that we've got this sort of thing going on. And the other parts of the immune system then move in, and all the cells that are displaying these features of alarm bells ringing saying there's a virus in the neighbourhood, they get wiped out by the immune system to destroy anything that might be trying to gain a toehold. So very often we're completely protected by this from fairly low-grade pathogens. But many viruses are tough cookies, and they have adapted and evolved to bypass some of these things. They know which wire to cut so that when they break in, they go trim, 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 and they dismantle and disable and bypass, at least for a period of time, many of these defences, so they can still gain the ability to replicate. Now, it's possible that there are people who get a low input of this virus. It produces very trivial symptoms in them, doesn't produce a very dense infection, and just gets booted out before they've actually made much of a response to it. It's possible that those people then don't make much of an antibody response. But because we just don't have the measure of this yet, we don't know. So it's a very good point that's being made. And it may be that only the people we're detecting with antibodies are the ones that actually have got a very good penetrating, dense infection. There may be people who get a very marginal infection. And in fact, the guy I was best man for at his wedding, he was at medical school with me. His wife is a health visitor. They live in the East End of London, where there's been enormous numbers of cases among the Bangladeshi community. So she's been a health visitor to many of those individuals. They had a situation where he has tested positive for antibodies. They definitely had symptoms in some members of their family, but both she and one other member of the family, nothing, no test. No results. And so it's very, very interesting because most of the cases do transmit well within families. So it just goes to show how variable this is, and you would expect those members of that family to have had it, but they do and do not seem to have tested positive. So this is how much of a mystery this is. As one doctor described it to me, this is the weirdest virus that many doctors have ever seen.
Only a couple minutes left. Here's a question. We're approaching level 1. We're going to continue to keep our borders closed for some time. And we're going to be screening or testing. Steve says that rather than quarantining everyone for 14 days, as we intend to do, he'd heard that 3 negative results on consecutive days was pretty much 100% sure that you haven't got COVID-19. And as long as people are willing to pay the cost of the tests, this could get tourism and business moving a lot more quickly. Could that be the case?
Well, the incubation period can be quite long, and it may be up to 11 days. We use 14 days to be safe. Therefore, if you got infected at the airport and you flew into New Zealand and then got tested on 3 consecutive days, it's not a given that you're definitely going to have enough virus there to detect it. So I think people would be uncomfortable about that, especially given the fact that New Zealand's got everything to lose. It's effectively achieved elimination status or close to, and the only thing that's going to happen is if you're at the top of the hill, the only direction is down, isn't it? So I think they'd have to be made much more satisfied that a person wasn't infected than just let's do a bunch of tests.
All right. Thank you, Chris. Dr. Chris Smith, Cambridge University virologist, and thank you for all your questions. I'm sorry we don't get through them all, but hopefully we get through a satisfactory amount for you.